Hello there guys, and welcome back to another epic inexorable maths video. In this one we're looking at arc length once again, link in the description to the first video on arc length. This is the second one. Find the length of the curve described by y equals the natural log of cos of x from x equals 0 to x equals pi over 4. I've drawn an absolutely amazing Mona Lisa over here of the graph. So we've got x-axis, y-axis, and I've drawn y equals the natural log of cos x. It kind of looks like that. You've got an asymptote at pi over 2, and we want to go from x equals 0 to pi over 4. And the question is, what is the exact length of the red line? Okay, not the area under the graph, none of that, although we will be doing integration. We would like to find the length. Now, how do we do it? So guys, remember a very important formula. Shall I write it down? I think I will. Because it's only the second video, so I think it's completely okay to write it down. So the arc length, and I think I used S in the first video, is the integral from the two x coordinates, I say xa, xb, of the square root of 1 plus the derivative of the function squared dx. Okay, this is the formula. S is the exact arc length. Sometimes people use L instead of S, so don't be confused. It's okay. But that's what we're going to do today. So let's go straight into it because I've done enough yapping. Let's actually do it. So first of all, we need to find the derivative. That's the first thing that we should always do. So what is dy dx? Okay. Now, we're going to have to use the chain rule for this because we're doing a composite function. Y is the natural log of cos x. Remember, the way that you differentiate the natural log of a function is, and I'm going to write this down too, actually, because this will save us a little bit of time. Where should I do it? I don't want to go, I'll do it up here. Hopefully that isn't too confusing. But if y is the natural log of some f of x, then that means that the derivative, dy dx, is the derivative of the function divided by the function. This is just 100% worth just memorizing. Just remember this if you haven't remembered it. So we've got that situation where f of x is cos x. So the derivative of cos is minus sine, and we're just dividing by cos. And obviously minus sine divided by cos is minus tan x, okay? So the derivative of the function is actually minus tan x. Cool. Now, if we squared this, right, square it, boom, 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 because we're going to square it because it's squared in the formula, just to make sure that makes sense. This is just positive tan squared of x, right? Hopefully, because the negative sign is going to go. So that's the idea there. Lovely. That's tan squared x. And then let's actually try and, plug it in. So the answer that we're looking for, S, is going to be the integral from 0 to pi over 4 of the square root of 1 plus tan squared x. Okay? Amazing. Now, the eagle-eyed viewers might notice 1 plus tan squared is sec squared. That's a trig identity. 1 plus tan squared is sec squared. So I'm going to rewrite it, integral from 0 to pi over 4, square root of sec squared, guys. So hopefully not too much of a leap to just directly go sec x right there. Okay, so we're actually just integrating sec x, and that is it. Okay. Now, what is the integral of sec x? Now, I know I'm whipping out a lot of just like, you should know this, you should know this, you should know this. Promise you, this is the last one, okay? This one, it's technically a standard integral, but it's one of the more elusive ones. The integral of sec x is the natural log of the absolute value of tan x plus sec x, or sec x plus tan x, okay? Plus c, but let's not go there. Okay, so that's what we've got. So I should do it over here. Okay, so it's just going to be, in big brackets, the natural log of tan x, okay, plus sec x. Boom, 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 and then the limits of integration are 0 and pi over 4. Okay, like that. Hopefully that makes Sense? And then when I plug stuff in, I'm going to have the natural log of tan x plus sec x the natural log of tan of pi over 4 plus sec of pi over 4 minus, you know the drill, right? So it's going to be the natural log, and I am going to do this all in one go, guys. My hair's getting in the way. Hopefully this is not too much of a crazy leap, okay? So I'm going to just talk my way through it to save space and time. So tan of pi over 4 is the number 1, okay? So the number 1. Sec of pi over 4, remember sec is 1 over cos. Cos of pi over 4 is root 2 over 2. So sec is 2 over root 2, the reciprocal. So 2 over root 2. And yes, we'll come back for that. We'll simplify it in a mo. Let's move that out the way. Okay. And then we're going to subtract the natural log of tan of 0, which is 0, plus sec of 0. Now, sec of 0 is 1 over cos of 0, and cos of 0 is 1, so it's 1 over 1, so it's just 1 again, okay? Lovely. Now, obviously, this natural log situation here, this whole thing is literally 0. It's equal to 0, so we don't want it, because the natural log of 1 is 0. And this is the natural log of 1 plus, and what is 2 divided by root 2, right? Well, 2 is 2 to the 1, and root 2 is 2 to the half, so it's just 2 to the power of 1 minus a half, so 2 divided by root 2 is root 2 as well. Okay, and that's the answer. So the answer to the question is that the exact length is the natural log of 1 plus root 2, okay? This is the final answer here. This is the exact length of the curve. Whoa, what a doozy, guys. I know I whipped out a lot of, casting a lot of spells, but yeah, hopefully that was nice and enjoyable. Thank you so much for watching. As always, I highly appreciate it. Friendly reminder, you will never, ever, ever see a mid-roll ad on this YouTube channel, ever. I do not believe when you're watching a YouTube video for educational purposes, you should be interrupted by an advert. No, no, no. We do not enjoy this late-stage capitalistic society that we live in. So if you ever see a mid-roll ad in my video, leave a comment. I will come in and I will remove it, okay? So thank you so much for watching. Highly appreciate it. I'll see you in the next one. Cheers.